We'll run through the last couple of examples, maybe try them out before we go over them together, and figure out what you would use to find the radius of the circle. Okay, so number 7, here's what you should notice, that chord CA and chord DF are equidistant from the center. The center is P there. The distance of CA to P is segment BP, which is 3, and then the distance of DF to the center P is segment EP or PE, which is also 3. So what that means is if the distances are congruent from the center, then the chords are actually congruent. So here's an equation that you could set up. 5x minus 2 is equal to 3x plus 2. If you solve that for x, subtract 3x from each side. I'm going to add 2 at the same time. 2x is equal to 4, so x is equal to 2. Okay, be careful. Some people might think that they're done right here. It doesn't say find the value x. It says find the radius of the circle. So here's what we need to do as well. We can find the length of either chord AC or DF from here. It doesn't matter. They're congruent. They're the same distance away from the center as well. I'm just going to substitute x back into this expression. 3 times 2 is 6, plus 2 is 8. So DF is 8 units long for DF. Again, we want to find the radius of the circle. Okay. So in order to find the radius, if we extended PE to a diameter, it's perpendicular, so it would bisect it. Since DF is equal to 8 units, then DE should be half of that, 4 units, because DE should be congruent to EF. So DE is 4 units in length. You might be wondering, well, that's not the radius either, but here's a radius in that triangle from P to D, from the center to a point on the circle. Notice what I created as well, a right triangle right here. PE, I'm going to redraw it down here. This is P, here's E, and then here's D. PE was given. That was the distance from the center to chord DF. That's 3 units in length. We just found the length of ED, which is 4 units in length. And then we could use the Pythagorean theorem to find the length of PD. Again, PD is a radius in the circle. So if we find the length of PD, we found the radius of the circle. And that's what the question asked. So again, we could use the Pythagorean theorem. I'm just going to let this be x instead of PD. But 3 squared plus 4 squared is equal to x squared. Maybe you already know the value of x, but if I solve it, 3 squared is 9, 4 squared is 16, it's equal to x squared. 9 plus 16 is 25 equals x squared. If I take the square root of each side, then x would equal 5. I said you might already know, the value of x, because if you started off with 3 and 4, if you remember our Pythagorean triples, 3, 4, and 5 form a Pythagorean triple. Okay. Try number 8 on your own. Pause the video. See if you can come up with the answer before we go over it. So on number 8, you're given the length of chord UV. It's 20. Chord WX is 20. So those chords are congruent. That means they have to be the same distance away from the center. So OY should be congruent to OZ. Then the equation that you could use or set up is 4x minus 5 is equal to x plus 4. And then solve that for x. So 4x minus x is 3x. On the right side, it's just 4 plus 5, 9. If I divide each side by 3, then x is equal to 3, which means we can find the distance from either of these chords to the center. This might be easier to plug in x here. 3 plus 4 is, this length would be 7. And then if you extended OZ, since I'm going to use chord WX, I could have also used chord VW. I don't need to use both to find the radius of the circle. But if I extended segment OZ to a diameter, it's perpendicular to this chord, WX. Therefore, it's also the bisector. So WZ is equal to ZX, or those segments are congruent. Okay, if WX is 20, then WZ would have to be 10. And then I could find the radius by drawing from the center to a point on the circle, a segment OW. OW would be a radius. And then I just redraw the diagram because there's quite a bit going on there. WZ is 10 units in length. WO or OW is what we're trying to find. That's a radius of the circle, but OZ was x plus 4. We found the value of x. That's 7. So again, I could use the Pythagorean theorem to find the radius. I'm going to call this r instead of x like on the last example because it's the radius. And then we could use the Pythagorean theorem. 7 squared plus 10 squared is equal to r squared. So 49 plus 100 is equal to r squared. So r would be, if I added these, 149, and then you take the square root. The square root of 149. It didn't say what to round it to. I'm just going to round it to the nearest tenth. So the square root of 149, about 12.2 would be the radius. Or in simplest radical form, you would just leave it as the square root of 149 because 149 doesn't contain any perfect square factors.